Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2020 Combined Science Physics Paper 2 Higher Tier. Question number 5 is on the topic on waves. X-rays form part of the electromagnetic spectrum. Radiographers use X-rays to produce images of bones inside the body. Explain why X-rays can be used to produce images of the bones inside the body. So, they're basically asking how does X-rays actually work, right? Now, when we have an X-ray, they use what is called a photographic film, right? So let's say that's a photographic film. This is what you actually get given at the end of the X-ray, right? Very similar to the old style photographic films. Now, that is usually covered. It's not exposed to light. If it's exposed to light, it becomes dark, right? If it'll go black. Now, if you put your hand on top of it, let me draw a really basic hand here. Oops, probably more than 5 fingers, right? Okay, right. So if you put your hand and if you expose that, if light falls on this part becomes dark, and this part is lighter in color, right? Very similar thing happens. Now, when we go for an X-ray, the part of the body that we want to take an X-ray, let's say I have a broken arm or a wrist, I've damaged my wrist. I put my wrist on top of the photographic film and we expose that to X-ray, and the X-ray can actually will go through this part will be dark, but at the same time, when it hits the bone, the bones actually absorb the X-ray, so it won't actually go through. So that part, wherever the bone is, it will actually be lighter. But let's say there's a small crack in the bone here, right? The X-ray will actually go through that small crack, and you will actually be able to see that small part where it's actually damaged. That's how X-rays work. So, answer for this: X-rays are absorbed by denser material like the bone, but can pass through flesh, right? So skin, the muscles and the blood, all of that is not dense enough for to stop the X-ray, so they will simply pass through. So you're not going to see an entire hand, you will just see the bones in the X-ray rather than the entire hand, like in a photographic film using light. Question 5.2. The table shows the effect of exposure to different doses of radiation. So you've got 100 milli SV is for sieverts, I think, yeah, and 1000, 5000 effect on the human body. At 100 millisieverts, slightly increased risk of cancer. At 1000, 5% increase of cancer. At 5000, high risk of death. During an X-ray, a person receives a dose of 0.5 millisieverts. A radiographer takes many X-ray images each day. So this is the person who's actually being exposed to the X-ray. So a radiographer is probably going to be exposed to a dose less than this, right? Explain why the radiographer stands behind a protective screen when taking an X-ray. Now, if you had any experience of having an X-ray being taken, you'll remember that they'll set it up and they'll ask you to stand still, and they'll go to a different part of the room or behind a screen, and then usually press a button, and then within a couple of seconds they say that's done, that's the end of it, right? So the reason they do that is if they are constantly near it, yes, they are going to be exposed to X-rays a lot. So by standing behind the screen, they're actually moving away from the X-ray, right? So taking lots of X-rays would give a large dose when it adds up little by little, right? Which would increase the radiographer's risk of getting cancer, right? Standing behind the screen absorbs some of the X-rays, right? So in effect, the screen reduces the risk and the dosage received by the radiographer. Right? So for 3 marks, if they are exposed to the X-ray too much, right, it will increase the risk. So because the screen absorbs some of the rays, we can reduce the risk for the radiographer. And usually they work on a rota where they are not actually working throughout, so they share jobs with other people, so they actually rotate from time to time, right? Question number 5.3. Radio waves form part of the electromagnetic spectrum. Figure 10 shows one use of radio waves. Explain how electrical signals in the transmitter produce a signal in the receiver. So how are electrical signals in the transmitter able to produce a signal in the receiver, which is over here, right? So the best analogy is to compare this. So you're going to have radio waves being produced, right? And that should be received here, right, by the receiver. So think of this like a water wave, right? Like water, right? And you have a floating object, right? Let me draw it like a person. And you have, let's say, another person here, right? Now, if the water level is flat here, right? If this person moves the water up and down to cause a wave, right? What happens is the wave travels forward, a transverse wave, and the energy is passed along. And when that energy is passed along, it causes the person on this end to actually move up and down, right? So although this person is actually not connected to this person, they're passing the energy through the medium. Something very similar happens over here as well. Explain how electrical signals in the transmitter produce a signal in the receiver. So in the transmitter, what you have is an AC current. An AC current, it is an alternating current where the current is constantly changing direction. So if you get a single wire and pass a current through it, it produces a magnetic field, and if at high frequency, if you change the frequency, it can produce an electromagnetic field, which is basically radio waves, right? So the AC electrical current, right? The AC electrical current, right, or oscillations produce radio waves in the transmitter. So this AC current will produce a radio wave here, and when these radio waves are received by this receiver, these radio waves are absorbed. This word is important, right? Is absorbed by the receiver, which induces an AC electrical current or oscillations in the receiver. So it causes an AC electrical current. So think of that if you're an electron, right, in this transmitter, because of this alternating current, that electron direction is actually constantly changing, which produces this radio waves. That radio wave is actually absorbed by an electron in the receiver here and causes that electron to oscillate in the same frequency. So if it's, let's say, oscillating at 50 hertz, this will also cause it to oscillate at 50 hertz. The same way, compare this to the movement of the person. So if this person is pushing the water up and down, let's say creating 2 waves per second, eventually when that wave is received here, right? That person is also going to bob up and down twice every second. Right? Hope that makes it clear. These two questions are actually level 8 and above questions, I think, and they are hard, right? Unless you revise for it specifically. Most students actually seem to skip this question, right? So the last part is to mention that they are at the same frequency that is actually being produced. That brings us to the end of this question. I will see you in the next video.